from Japan. So he worked in the conducting polymers. Basically, friends, which has built in commemoration of the awarding of Nobel Prize in Chemistry for Hideki Shirakawa, and I work in the same building. So Hideki Shirakawa, he synthesized the polyacetylene films for which he got the Nobel Prize, which were later found the conducting polymers. So let us start the webinar. Before that, located, which is a memorial room for these three Nobel laureates, and they have put the exhibition of, I mean, the equipments which they have used for their experiments, which led to the Nobel Prize. So it's a really good opportunity for budding researchers like me. So let us start the presentation. Outline of my presentation. So I would briefly introduce what is a material science, then various applications of material science, such as energy conversion materials and energy storage materials, then various tools which we use for the materials characterization. And at the later part, I will discuss the career opportunities after BSc and MSc in research abroad. So, material science is the study of properties of solid materials and how these materials properties are determined by materials composition and structure. It deals with the material science. Based on the conductivity or resistivity of any material, material can be categorized into three types. Those are metal, semiconductor, and insulator. Now, there is a basic entity which distinguishes these three types of materials, that is called as a band gap. So, band gap is the difference between the valence. It is the difference in the energy between the valence band and the conduction band. Valence band is full of electrons, while conduction band has bands are empty of electrons. In case of metals, these two layers are overlapped. Therefore, the electrons are easily available for the conduction. That's why metals are highly conducting of the electricity. Semiconductors are insulator at the room temperature. But if you give the temperature to the semiconductors, they can be made conductors. For example, when the temperature is provided to the semiconductors, the electrons from the valence band get migrated towards the conduction band, leaving hole behind. Hence, the conduction mechanism starts in the semiconductors. So, when the electron migrates at the valence band, it leaves behind hole. So, this electron and hole pair is also called as exciton. You can see there is a dotted line in between the valence and conduction band. This is a EF, which is a Fermi energy level, which is the probability of highest occupancy of the maximum charge carriers, be it the electrons or be it holes. So depending on the maximum charge carriers, the Fermi level alignment is different. In case of P type, it is towards the uh, conduction band side, and in case of N type, it is towards the electron side, that is the valence band side. In case of insulator, the band gap is very huge. Even if you supply the external energy, the electrons cannot overcome the barrier of the band gap. Therefore, insulators are insulators at all temperatures. Now, these are the different kinds of materials. So, these materials are studied for the different practical application. For example, we can use the different semiconductors for the energy conversion, and we can use different kind of metals and conducting polymers, for example, or metal oxides for the energy storage. So I would like to discuss few examples of these practical applications, such as solar cell and photoelectrochemical water splitting and the supercapacitors. Let us start with the energy conversion and storage devices. In the day-to-day life, we are very dependent on the different electrical energy sources or fossil energy sources, and those are all very essential for our day-to-day life. But these energy sources are harnessed from the fossil fuels, which are at the verge of the depletion. Therefore, we need an alternative energy resources. As you can see, the scientists say that only next two generation will see the fossil fuels as energy source. So, in order to tackle this problem, we need to have alternative energy source which is free from the carbon, because the carbon dioxide is responsible for the global warming. You know that because of the combustion of the fossil fuels, it generates the carbon dioxide, which is the major uh, it is a major gas which is responsible for the air pollution, which leads to the global warming effect. And in order to cap the CO2 at the 550 parts per million, which is the safety limit to avoid the global warming, we need to have renewable energy sources to be used. Now, if we look at the energy scenario of the globe, the current global power consumption is around 13 terawatt. And if we assume that look at the rate of the power consumption now, the global power consumption in 2050 is expected to reach around 28 terawatt. And when we look at the solar energy, it is the largest non-carbon based energy source, which can generate around 10 raised to 5 terawatt of energy. If we are able to harness at least 1.5 hour of the solar energy, it can produce 14 terawatt of energy, which is the current global power consumption. So that's why we need to harness the solar energy for the generation of electricity. These are the some major renewable energy resources free from the biomass, free from the fossil fuels, be it a biomass, be it a solar energy, be it a geothermal energy. There is a wind energy and hydroelectricity from water. So these are different kinds of major renewable energy resources. Now look at the sun's energy, how much solar energy is fallen on the earth and how much solar energy we can utilize. 24% of the solar energy we can use for the conversion of electricity, and the rest of the 76% energy is wasted. For example, around 34% is absorbed by the atmosphere and 25% is absorbed by it is scattered. So we need to concentrate on the solar energy, which is abundant in the nature. Now, how to convert the solar energy into the electricity? So, such phenomena is called as a photovoltaic effect. As we discussed earlier, when a photon of light is incident on a semiconductor, electron and hole pairs are generated. The movement in the electron field generates the current, while the movement separation by the electron field generates the voltage, and the power is the product of voltage and current. Now there is a condition for the electron hole pair generation. The photon of light should be or equal. It should be greater than or equal to the band gap of semiconductor. Then and only then it is possible to generate the electron hole pairs, and we can harness the solar energy and convert it into the electricity. Now there are different generations of solar cells, right from the first generation, second generation to the third generation solar cells. Now, the first generation solar cells consist of single crystalline silicon solar cells. It has a maximum theoretical efficiency limit, which is around 33.7%, which is also called as a Shockley-Quasar limit. And the maximum achieved practical efficiency nowadays, it is 27% for the single crystalline silicon solar cell. But the first generation solar cell suffers from the drawbacks. For example, these kind of solar cells are very much costly because uh, it requires, I mean, the manufacturing process is very tedious and it is very expensive. That's why the first generation single crystalline silicon solar cells are very costly. Therefore, scientists moved towards the second generation solar cells, where they utilize the amorphous silicon, CIGS, which is a copper indium gallium sulfide, CDTA cadmium telluride, then CZTS. CZTS is copper, zinc, tin, sulfur thin film solar cells. In second generation solar cells, also the maximum theoretical efficiency is around 33.7%, but the achieved efficiency, the practical achieved efficiency is around 19%. If we look at the second generations of solar cell, those are the low cost as compared to the first generation of solar cell because of the earth abundant minerals which we are using here. Like for example, for the copper, zinc, tin sulfide, these are the earth abundant elements which we are using in the second generation of solar cell. That's why the cost is reduced. But the theoretical, I mean, the achieved efficiency, the practical efficiency is not that much in order to utilize them as a practical solar cell. And in these kind of two generation of solar cell, there are limitations in the efficiency because of the thermalization of excess energy in the semiconductor, and there's a practical difficulty below the band gap photons are not absorbed in case of these kind of solar cells. So scientists moved again to the third towards the third generation of solar cells. Now the third generation of solar cells consists of dye-sensitized solar cells and quantum dot sensitized solar cells. And presently the hot topic is the perovskite solar cell. So these are the third generation of solar cells. Actually, dye-sensitized solar cell is inspired from the leaf, plant's leaf. The photosynthesis process which occurs in the plant's leaf is analogous to the dye-sensitized solar cells. Here, in case of these kind of solar cell, that is the third generation of solar cells, the maximum theoretical efficiency is assumed to be 44% for the DSSC and for the quantum dot sensor solar cell, and it is 31% for the perovskite solar cells. And if you look at the maximum achieved efficiency for the dye-sensitized solar cells, it is around 12%, and for the quantum dot sensitized solar cell, it is around 11%. And these are still in the research phase. But the additional advantage of these kind of solar cells are the material which we use here are very earth abundant and eco-friendly, and which are readily available, and it is possible to synthesize these kind of solar cells at the laboratory scale. And for the perovskite solar cells, the achieved efficiency is around 22.1%, but there is a stability issue in case of perovskite solar cells. Therefore, the research is ongoing. If you look at the third generation of solar cells, these are very low cost, as I said, compared to the both first and second generation of solar cells. Out of these three kind of solar cells, I would like to discuss one kind of solar cell, which is quantum dot sensitized solar cell. Let us look at the structure of quantum dot sensitized solar cell. It consists of two uh, electrodes. One is a photocathode and one is a photoanode. Now, the photoanode consists of glass which is coated by FTO. FTO is a conducting layer, which is also semiconductor, on which the titanium oxide nanorods are grown using simple chemical routes. And these nanorods are decorated with the CDSC kind of nanoparticles, which are having a low band gap. Or you can say these are CDSC quantum dots. Now the photocathode is again consists of glass FTO, and it is coated with the platinum. This constitute the photocathode, and the photocathode is provided with the pre-drilled hole in order to insert the liquid electrolyte. And in order to avoid the short circuit, we use the spacer in between these two electrodes. This is how the structure of quantum dot sensitized solar cell consists of. Now look at the mechanism of the quantum dot sensitized solar cells. When photon of light is incident on a CDSC nanoparticles, electron and hole pairs are generated, which is shown in this figure. So it is also called as a nanoparticle excitation. So when the incident light is fallen on the CDSC nanoparticle, electrons migrate towards the CDSC conduction band, and then through the TiO2 conduction band, it goes to the FTO, and again it comes back to the platinum FTO. The second process is the electron injection, which we have seen from the CDSC conduction band to the TiO2 conduction band. In the third process, the electron regeneration takes place. That is, the electrons from the liquid electrolyte generates the hole. I mean, it recombines with the hole in the valence band of the CDSC nanoparticle. So it is the regeneration process. In the fourth procedure, electrolytic reduction takes place here, and later there are some undesirable processes involved in this quantum dot solar cells. There is a chance that this electron can recombine with the hole in the valence band itself. And in the fifth procedure, the relaxation of electron takes place without electron injection. It means the electron can be recombined from the TiO2 conduction band to the CDSC valence band holes. Later, these recombination with the nanoparticle takes place. So, in order to avoid these recombination losses, we have to modify the solar cell accordingly. So, this is how the quantum dot sensitized solar cell works. So, the photon of light is incident, then electron hole pairs are generated in the CDSC nanoparticles, and these electrons migrate towards the TiO2 conduction band through the FTO and to the external circuit. And because of the liquid electrolyte, there are redox reactions are taking place. So this is the electron is again reduced at the platinum FTO, and it is readily available again. Uh, and this process continues unless the solar light is incident. This is how the electricity is generated. Now let us move towards the second application, which is a photoelectrochemical water splitting. Again, it is analogous to the quantum dot sensitized solar cell. It consists of two electrodes. One is a photoanode and one is the photocathode. So usually oxygen evolution reaction takes place at the photocathode, and hydrogen evolution reaction takes place at the photoanode. The reaction mechanism is again similar to the quantum dot sensitized solar cell, but the functioning, I mean, the materials which we use here is different. In case of quantum dot sensor solar cell, the photocathode was a platinum FTO, but here we can use two different semiconductors as a photoanode and photocathode, which can simultaneously generate oxygen as well as hydrogen. And you know that hydrogen acts as a fuel. So in the market nowadays, hydrogen fuel cells cars are also available. So it is a clean source of energy which is used for the I mean for the daily commuting for, in case of hydrogen powered cars. And now let us discuss about the photoelectrochemical water splitting very briefly. It is based on the conversion of light energy into electricity within a cell, it involving two electrodes immersed in an aqueous electrolyte. Now, aqueous electrolyte, it is an electrolyte which is water based, of which at least one is made of a semiconductor and another is either metal, or we can use a semiconductor also, which absorbs the light. Now, this electricity is then used for the water electrolysis. I mean, it means the you are splitting the water to generate the hydrogen and the oxygen. There are three options for the arrangement of photoelectrodes in the assembly of photoelectrochemical solar cells, photoelectrochemical cells. That is photoanode, which is made of N-type semiconductor, and cathode is made of metal. This is one possible example. Another example is photoanode made of N-type semiconductor and photocathode is made of P-type semiconductor. And lastly, either photocathode is a P-type, then the anode is of metal. So these are three different kinds of photoelectrochemical cells, which are used for the water splitting purpose. So this is one example of again storing the energy. We initially saw the solar cell, which is a harnessing energy. Now the photoelectrochemical water splitting is used for the storing the hydrogen energy. Now the last example of the electrochemical device is the energy storage device. Now we have seen the this 21st in the 21st century, we are all dependent on the different energy kind of sources, but energy production from sun and wind is very essential to avoid the global warming effect. But as you see, sun does not shine during the night and wind does not flow on our demand. So therefore, we need a better energy storage device. And one such kind of energy storage device is electrochemical capacitor, which is also called as supercapacitor. Now, why supercapacitor is essential for the energy storage? Now, look at this graph, which is also called as a Raygon plot. It is a graph between a specific power density against the specific energy density. The batteries are having high specific energy and moderate specific power density. Supercapacitor lies in between the capacitor and battery. It means the supercapacitors are having high power density and high energy density. Now, what are these two terms, energy density and the power density? Energy density means the ability to store the charges, and power density means how fast the power is delivered to the output or to the load. So supercapacitors have high energy density. It means they can store maximum amount of energy, and as well as they have high power density. It means they can discharge very quickly. But in case of battery, they can store the charges for longer time, and even the discharge time is also long. So supercapacitor and battery, if we combine, then we can have a miracle in the hybrid electric vehicles. So that's why supercapacitor are mostly used in the acceleration of vehicle or in the braking of the vehicles. So this is a kind of a energy storage device. So if you look at the energy storage mechanism in the normal capacitor, the two parallel metallic plates are separated by the dielectrics, and this dielectric thickness is around 1000 nanometer. But in case supercapacitor, basically these are two types of supercapacitor: electrochemical double layer capacitor and pseudo capacitor. Actually, in case of double layer capacitors, the important characteristics of the electric double layer, which appears, for example, at the interface between the conducting electrode and an adjacent liquid electrode. At this boundary, layers of charge with opposite polarity form. One at the surface of the electrode and one on the electrolyte. These two layers, electrons on the electrodes, ions in the electrolyte, are typically separated by a single layer of solvent molecules that adhere to the surface of the electrode and act like a dielectric in a conventional capacitor. Now, the amount of electric charge stored in double layer capacitor depends upon the applied voltage, and the unit which we use for the capacitance is a farad. So, this is how the electrochemical double layer capacitor works. So, the double layer thickness is less than 1 nanometer. Now, how the pseudo capacitor works? The pseudo capacitor basically here the charge storage mechanism occurs with the faradically. It means there are redox reactions are taking place. This is accomplished through electrosorption and redox reaction. Now, redox reaction means oxidation and reduction reaction. Oxidation is loss of electron, and reduction is the gain of electrons. You know that. So this is how the pseudo capacitor works. So these are the different kind of supercapacitors. Now, when you combine these two kinds of supercapacitor, double layer capacitor and pseudo capacitor, it results into the hybrid capacitor. So electrical double layer capacitors requires carbon metals, which carbon metals are basically used for the double layer capacitors, and pseudo capacitors, metal oxides and conducting polymers are used as a pseudo capacitor electrodes. Now let us move to the different characterization tools for the analysis of these materials. X-ray diffraction technique, you might have heard about this, and basic mechanism of X-ray I'm not discussing here. In order to determine the crystal structure and the phase of material, we use the X-ray diffraction tool. Then we can analyze the morphological features, or we can analyze the surface chemical composition and the valence state of material using X-ray photoelectron spectroscopy. So XPS is used to know the valence state of chemical composition. So whether the material is in pure form or not, we can determine using the XPS technique. Now, the morphological features play a very important role whenever we study a material. For example, in case of capacitor, the porosity of material is very important. Therefore, and in case of solar cell, again, the nanoparticle size and the nanorod's shape and size of the nanoparticles is very important. So, scanning electron microscopy gives it determines the surface morphology and it gives the thickness of material. Next technique we use is the transmission electron microscopy. It is also called as a TEM. It is used to determine the surface morphology and interplanar distance of a crystal lens and elemental mapping of a material. The composition of a material we can determine using the transmission electron microscopy. Now, optical absorbance is a very important tool to analyze the absorbance and transmittance in a material. In case of solar cells, type of material is very important. So we can calculate the band gap of any semiconductor with the using optical absorbance technique. Next tool we use is the Raman and photoluminescence. Raman is used to study the molecular vibration in a material and thereafter to determine the structure of material again. But photoluminescence is used to study the band gap and defects in the material. So defects play a very important role in case of solar cells also. So some defects result into the reformation. Sometimes these defects are responsible to the increase in the solar cell efficiency also. Finally, the electrochemical workstation we usually use is this is used for the cyclic phototomogram or electrochemical impedance and charge discharge study of the supercapacitors as well as for the solar cell. In case of solar cell, we use the current and voltage measurement. So this is also possible using the electrochemical workstation, which is also called as a potentiostat. So this potentiostat, along with the solar simulator, we can use for the solar cell study. Uh, Here you can see there are three electrodes. One is the working electrode, another is the counter electrode, and third one is the reference electrode. So this arrangement is called as a three electrode system. So this is the final arrangement which we use for the application of solar cell or supercapacitor study. So far, I have discussed the various materials which we can use for the study in research. For example, we can use the materials for the solar cell, that is the energy conversion, and for the photoelectrochemical water splitting and supercapacitor, that is energy storage. So energy conversion and storage is very important aspect to tackle the energy crisis. Now, the most important aspect of this presentation, which these students are very, I mean, for the students, which is very interesting, is career opportunities after BSc and MSc in research. I would like to discuss the different fellowships which are available for the master's and PhD course throughout the globe. For example, in South Korea, the South Korean government gives the Global Korea Scholarship, which is also called as a GKS scholarship. Now, the age limit is for the BSc candidates, if they want to go for the masters, the age limit is below 25 years. And for the PhD course, if someone wants to go for the PhD course, they should have a MSc and their age should be below 4 years. This fellowship is for 4 years. Now, how to apply for this fellowship? You have to apply through the Korean embassy in respective country or through Korean university. It means you have to first search for the host, I mean the scientist or the professor under whom you would like to do your research. Then he will submit your application to the Korean government. And after the results, the announcement of the results, you will get to know whether the scholarship is awarded or not. Here they cover the airfare. They will give the actual cost of airfare in this fellowship. They will give you the resettlement allowance around the Korean won 2 lakh, which is around 200 US dollar. Living allowance they provide from 900 to 1000 US dollar, and they also give the medical insurance coverage around 20 US dollar per month. In case of this GKS scholarship, for the initial first year, you have to study the language. So the language course is offered in this scholarship. So first year you have to study the language. Then after the rest of the 3 years, you can do your research, which is very interesting one. Now, next scholarship is from the Japanese government, which is called as a Mixed Japan Government Scholarship. The eligibility for this scholarship is you should have a MSc and you should have 65% marks and your age should be below 35 years. Now, how to apply for this fellowship? You have to apply again through the Japan embassy in respective country. Like for example, from India, you have to apply through the Japan embassy in India, located at New Delhi, Mumbai, Chennai, and Kolkata at four different places. But in case of Maharashtra, I mean, we should apply through the Mumbai consulate. The period of this fellowship is for 3 years. Now, how the selection takes place: document screening, written examination, and interview. In this case, so what are the benefits of this scholarship for the students who wants to do the regular course? 1,43,000 yen, which is around 1 lakh Indian rupees per month, is the stipend given. And the student who wants to pursue the doctoral degree, the scholarship is around 1,45,000 yen, which is around 1,02,836 per month. Education fees, like the tuition fees, are exempted in this scholarship. The Japan government provides you the traveling expenses, like the round trip airfare will be provided for the students who are selected for the next Japanese government scholarship. One more important thing we should consider is, if you have a Japanese language ability, the chances of getting the next scholarship is high. So just please consider about this. Next is the German fellowship, which is also called as a DAD scholarship, German Academic Exchange Service. Now again, the eligibility is similar: 65% marks in the BSc, MSc, and your age should be below 35 years. You can apply through the DAD website, and the period is very small, which is around 1 to 6 months. It's kind of a uh, internship you can apply. Again, the selection process is document screening, and you have to write a proposal. I have provided the website here. I can share this information with Karanskar sir, so that he can let you know. Now the scholarship benefit is depending on the academic level. The monthly payment is around 861 euros for graduates and 1200 euros for the doctoral candidates and postdocs. It again consists of health, accident, and the personal liability insurance coverage. Next fellowship is the Marie Curie Action Doctoral Network Scholarship, which is available in the Europe. Eligibility is you should have a master's degree. You can apply through the website, and it is the vacancies mentioned in the on the website. So you should search for the vacancies available throughout the Europe. The period for this Marie Curie fellowship is again for 4 years. Selection is a similar: document screening and interview. This is the website you can apply through this scholarship. Actually, the scholarship benefits are not mentioned specifically, but the European Union provides support for each recruited research in the form of living allowance, mobility allowance, if applicable. If you have a family, long-term leave and special needs allowance are also provided. In addition to that, funding is provided for your research training and networking activities, as well as management and indirect costs. These are the other costs which are covered under this fellowship. You might have heard about this kind of this famous fellowship, which is given on the name of former Prime Minister Dr. Manmohan Singh. It is called as a Dr. Manmohan Singh Scholarship, which is available in the United Kingdom. Your age should be below 35 years, and you should have a master's degree. You have to apply through the university which are based in the UK. The period for this scholarship is again 4 years. Selection procedure for all the fellowships are say similar. You have to send the document screening, and you will have an interview over after the selection. Then the results will be declared. This is the website. Actually, the scholarship benefits are not mentioned specifically, but it covers the fees and living cost of your education. Then this is a Canadian fellowship, Vanier Canada Graduate Scholarship, which is again for the doctoral course. You can apply through the university, and it is as an you have to be nominated. I mean, you have to search your host. Your host nominate you for this fellowship, and this scholarship period is again for 3 years. Selection is based on your academic excellence, your research potential, and leadership ability. The scholarship benefit is $50,000 per year for 3 years during your doctoral degrees. So thank you so much for your patience, and especially thanks a lot to Dr. Karanskar sir for inviting me to give a webinar before BS and MSc candidates about the research in material science, as well as the career opportunities for them. Now the questions are welcome from the students and audiences.
Patience, guys. मराठी बोलायला चालेल.
हा मराठीत तरी प्रश्न असले तरी विचारू शकता, काहीच प्रॉब्लेम नाही.
आहेत काय क्वेश्चन्स? एनी क्वेश्चन्स? Sachin sir,
हा सर.
I have a small question.
Yes sir.
You have nicely presented all the scholarships regarding the students, but is there any scholarship for teacher for short interval?
Yes, sir. This is very nice question actually. If the faculty, I mean, he is having a permanent job in India, like
Okay.
assistant professor kind of things, he can apply
Ah,
for the Brain Pool Fellowship, which is available for the South Korean Korea. And for the Japanese government, there is a 10 months fellowship, which is again similar to me. JSPS fellowship is available for the faculty for
okay.
10 months period. And in case of Brain Korea, BK fellowship, which is I think 1 year uh, for the faculty. Yeah.
Okay. Thank you, sir. Uh, very nice to see you that you are living in a Nobel laureate atmosphere, and also feel proud, sir, because you are a colleague of me, and I am very much thankful, uh, Professor Sachin Pawar, sir, for his valuable guidance. He explained all the facts, figures regarding the energy sources, energy storage, and lastly, he also explained what are the opportunities for BSc and MSc aspirants regarding the scholarships, different types of scholarships. So, on behalf of Physics Department and Vivekanand College, Kolhapur Autonomous, I am very much thankful to Professor Sachin Pawar sir, and I hope that our student will take the inspiration from your lecture, and your presentation is always very nice and simple, and the language is very very lucid, so we enjoy your lecture. Thank you, sir.
Thank you so much, sir. If the students want to pursue their career in research, they can contact me anytime. You can contact to Dr. Nawate sir, or you can contact to Dr. Karanskar sir, who know me personally. If you want to apply for any kind of fellowship, I can help you anytime. Thank you so much again.
Thank you very much, sir.
Thank you, sir.
Thank you, sir. It's very nice to meet you, sir. Due to some technical problem, instead of 1:30, it is 15 minutes late. So, sorry for your inconvenience, sir.
No, sir, no problem. I can understand the situation in India. No problem. I can understand.
And sir, one more thing I have to told you that we are going to organize an international conference on
Okay.
nanomaterials and nano devices under the
Okay.
guidance of Dr. P.S. Patil sir. We are organizing this conference on the 4th May. I will
I
send you details about it. So
okay.
if it is possible to you, then please go through it and make your convenient to attend it. And
Yes, sir.
further our request is that if it is possible to you, then please send your poster or your one paper because your work is very nice, and we are publishing these papers in ISN Vivekan College. So that Vivekan College have one research paper, that is Vivek Research Journal, with ISSN number. So it's my special request to you on the behalf of Vivekanand College, on the behalf of PG department, and as well as from our TFML group. Okay, sir. Once again, thank you very much for your presence and valuable guidance to our students. Okay. Thank you, sir. Thank you, sir.
Thank you so much, sir. Okay.
Okay, okay, okay. Now we'll stop here. Yes.
Okay, sir. Okay, bye.
Bye.
Yes, sir.